Hello, everyone. We're going to give it a few minutes for people to join, and then we'll get started. Hello, and welcome to today's fiscal year 2023 Flood Mitigation Assistance and Building Resilient Infrastructure and Communities Notice of Funding Opportunities, Application Pitfalls, and Best Practices webinar. Before we begin, I'd like to provide a few housekeeping notes on today's Zoom webinar. If you're encountering any issues with meeting bandwidth, please turn off any VPNs. For technical issues, you can ask questions via the Q&A pod at the bottom of the screen or via FEMA-HMA webinars at fema.dhs.gov. This email will be chatted to you momentarily. This webinar will include a presentation followed by Q&A. Throughout the session, we invite you to submit questions for our speakers via the Q&A accessible at the bottom toolbar. At the end of the session, we will ask you to respond to a few polling questions that will pop up on your screen. Today's session is being recorded for those who are not able to attend. I'd like to introduce today's moderator, CDM Smith Senior Project Manager, Eric Kenny.
Thanks, Eunice, and good afternoon. Next slide, please. So the purpose of today's webinar is to discuss some common project application pitfalls, best practices, and lessons learned from the review of hazard mitigation assistance applications. We'll discuss some common information gaps and review appropriate documentation and sources needed to develop a complete application. We'll start this presentation with a quick overview of key changes from the fiscal year 2023 Notice of Funding Opportunity, cover common pitfalls and best practices observed across all project types. These pitfalls are based on the observations of the National Technical Review Team, so really focus on technical feasibility and cost effectiveness. But we will also touch on key environmental planning and historic preservation, EHP considerations, before closing out with some additional considerations, helpful resources, and have some time for your questions at the end. Next slide. So to start off, just wanted to highlight some key changes to the Flood Mitigation Assistance Program for this year. There's a lot more details in the Notice of Funding Opportunity, as well as the Notice of Funding Opportunity fact sheet. So these are just some highlights. There was an increased level of funding for localized flood risk reduction projects. For mitigation reconstruction project types, the federal cap has increased to $220,000 from the $150,000 cap. FMA is using 3 of the Centers of Disease Control and Prevention, social vulnerability index themes, social economic status, household characteristics, and housing type and transportation scores for the enhanced federal cost share. And this helps provide a more nuanced approach to project funding. There also have been some changes to the final priority scoring criteria, tiebreakers, and thresholds that really aim to optimize project selection and ensure the most impactful mitigation efforts. This includes prioritization for properties meeting the Flood Mitigation Assistance and National Flood Insurance Program, NFIP, a definition of severe repetitive loss and repetitive loss, SRL and NRL. And then the equity data measures are evolving from the CDC SVI score that I just mentioned to the Climate and Economic Justice Screening Tool, CJEST, Justice 40 communities, as well as community disaster resilience zones. And these are intended to ensure a more comprehensive consideration of equity, as well as community needs and resilience. Next slide, we'll cover some of the key changes for BRIC. Key changes for BRIC this cycle to further demonstrate the importance that FEMA is placing on building codes. The BRIC program has made available $112 million for the states and territories, as well as $25 million for federally recognized tribes as building code plus-ups. The important caveat on this is this funding can only be used for eligible building code activities. From an equity standpoint, like FMA, BRIC is using the Centers of Disease Control and Prevention, moving from the Centers of Disease Control and Prevention, SVI, to CGEST and the Community Disaster Resilience Zones as the methodology for geographically identifying disadvantaged communities. Under the state and territory allocation, a minimum of $400,000 must be used on a combination of capability and capacity building activities or projects that primarily benefit these community disaster resilience zones. BRIC is continuing to request benefiting area maps. These maps should be submitted along with the associated geospatial files, and these will be used to FEMA to help determine if a project benefits or primarily benefits Justice 40 communities, community disaster resilience zones, and or economically disadvantaged rural communities. And this is for purposes of prioritization, cost share, and BCA technical assistance. I'll talk a little more about the BCA technical assistance, as well as the streamlined cost effectiveness on the next slide. But the final point that I want to highlight here for the BRIC program this year is that the scoring criteria have been updated. There are some details there at the bottom of your slide. But rather than try to wade into that, I would just encourage you to review the applicable program support materials, this including the Notice of Funding Opportunity and the Notice of Funding Opportunity fact sheet, which go into some detail on how the scoring has evolved for this cycle. Next slide, please. Perfect. So this is probably not news to folks, but FEMA requires that all hazard mitigation projects be cost effective. For this cycle, there are 3 approaches to demonstrating cost effectiveness. First and newest, for projects with a total cost of less than $1 million, so this is total project cost, not just federal share. The sub-applicant may provide a narrative that includes qualitative and quantitative data demonstrating the benefits and cost effectiveness of the project. Instructions for completing this cost effectiveness narrative can be found on FEMA's BCA benefit cost analysis website in the program support material. We will reference this website quite a bit through this presentation. Your favorite search engine will take you there, and we will have links to this at the end of the presentation as well. Pre-calculated benefits continue to exist and continue to get updated for a handful of project types, including acquisition, elevation, wind retrofit, residential safe rooms, hospital generators, as well as post-wildfire mitigation. So if either of these are applicable, that can help make the cost effectiveness demonstration a little more straightforward. But finally, you can, of course, and even if one of these previous efficiencies applies, you can always use FEMA's BCA toolkit to demonstrate the cost effectiveness of your project. Finally, just further details, including application submission requirements, as well as general program information can be found in the Hazard Mitigation Assistance Policy Program Guide, as well as on the FEMA BCA website. So next slide, talk a little more about BCA assistance. So similar to last year, FEMA will review hazard mitigation project sub-applications during the pre-award process that are competitive and otherwise eligible for selection for an economically disadvantaged rural community, federally recognized tribal government, or a sub-application that primarily benefits a community disaster resilience zone is unable to calculate a BCR to demonstrate cost effectiveness. So in these cases, FEMA may assist such communities with developing a BCA. Again, if your project is less than $1 million, the $1 million threshold applies, and the demonstration of this BCA assistance may not be required, and you won't need to submit a cost effectiveness narrative at the time of application. Again, more information on the specifics of how to demonstrate, how to assemble this narrative are found on FEMA's BCA website. I did want to just quickly highlight some of the differences in program-specific differences. So I mentioned BRIC, federally recognized tribes, economically disadvantaged rural communities, and projects primarily benefiting a community disaster resilience zone. For FMA, it is slightly different just due to requirements, but federally recognized tribes, small and impoverished communities, as well as community disaster resilience zones communities, can submit sub-applications without completing a BCA, and FEMA can provide technical assistance. I would certainly encourage you to submit the data you have available. That'll make the lift for the technical assistance lighter and hopefully streamline the final review and award process. And then finally, this is something that was, I guess, kind of previewed the last cycle, where certain applications could use a 3% discount rate. For this cycle, FEMA has established the 3% discount rate for using the BCA for projects under BRIC and FMA. So all projects using the BCA toolkit for this cycle can use the 3% discount rate. I will now turn this over to Mandy Perriton to talk through some common pitfalls and best practices across all project types.
Great. Thanks, Eric. Next slide, please. And as Eric mentioned, I'm going to be covering all project types, and then I'll be followed by James, another one of our colleagues, who's going to get into a little bit more specifics on each of the project types. So to start off, from a national technical review standpoint, to give folks context, under the flood mitigation assistance program last year, about 80% of the projects were recommended for further consideration, and that includes both a technical feasibility and a cost effectiveness review. And that's about relatively consistent with the past couple years of reviews. On the Building Resilient Infrastructure and Communities, or the BRIC program, it was about a 70% 70% of the sub applications were recommended for further consideration, and that was quite an increase. I think in the past couple of years, the average had been about 50%. So, so overall trend, at least using last year as an indicator, we are seeing improvements in sub applications, and hopefully the materials and these types of webinars are helping with it. And we encourage you to go out to the, as Eric pointed you to, the BCA, FEMA BCA website, and there's other program support materials available online. So with respect to common pitfalls across all project types, one of the most common ones is just unclear or an incomplete scope of work. And this can just include just something that conflicts with industry standards, or just conflicts within itself. A primary example that I can think of, a couple examples I can think of with respect to not meeting industry standards is not meeting FEMA P361 for a safe room, or not meeting FFRMS for an elevation project. Another pitfall is when a project does not conform with HMA requirements. The scope of work needs to comply with those requirements. And again, an example of this could be an elevation project that does not meet ASCE 24, which is a minimum requirement in the HMA requirements. Next slide, please. Continuing with pitfalls, another common item that we see is insufficient or lack of documentation. I want to make sure that any engineering studies that you reference in your narratives are provided. Oftentimes that's a key issue. A lot of information was provided in a narrative or in the sub application, but the documentation just wasn't provided. So make sure that you're providing that documentation. In addition, make sure you're supporting any of the assumptions that you're making, whether they be in your scope of work or that they're in your benefit cost analysis. We also want to make sure that the sub application is as consistent as possible. Sometimes we see inconsistencies in it. An example could be that you're recommending for two culverts to be installed, and the scope of work on, or excuse me, the cost estimate may only show one culvert. And that kind of comes to the last piece on this slide, the cost estimate issues. You want to make sure it's consistent with your scope. If you say you're elevating or acquiring 10 homes, the cost estimate should be consistent with that. In addition, it should be reasonable and supported. Next slide, please. On the cost effectiveness side, I'll get into a couple more common pitfalls associated with these. I want to make sure that your documenting or your documentation is consistent with the types of buildings and infrastructure that you're featuring. The primary example I can think of here is if let's say we're looking at a flood risk reduction project and the damages are being modeled, we want to make sure that the documentation is there for the lowest floor elevation. If you're doing a wind retrofit project or any kind of retrofit project, you want to make sure that the building type is consistent with across the documentation provided. Finally, you want to make sure that your benefit cost ratio in your sub-application matches the benefit cost in your sub-application. All the documentation should be consistent. Oftentimes we see a BCR of 2.0 in the sub-application, and the supporting documentation has 1.5, and we're not sure which one to go by. Next slide, please. Again, on the cost effectiveness side, you want to make sure that you're applying the appropriate module. And if you're using pre-calculated benefits, that the pre-calculated benefits are consistent with the sub-application and the situation at hand within your project. Again, common types of pre-calculated benefits, for those of you who are not familiar with them, there's pre-calculated benefits for acquisition projects, for elevation projects, for non-residential and residential wind retrofit projects, generators, etc. So if you're using those pre-calculated benefits, make sure you're meeting those conditions and properly applying them. Another common issue with cost effectiveness is how you estimated your recurrence interval. Make sure you provide documentation to support how those recurrence intervals are estimated. And we also expect, when we see severity of damage, to be consistent with the recurrence intervals. For example, at a 10-year recurrence interval, we may expect, let's say, $100 in damage with that 10-year recurrence interval. We would expect that 100-year to be those damages to be a lot greater, or the inverse. If you have a significant amount of damage at the 100-year, you would expect there to be less damages at the 10-year. So making sure the severity of the damages are consistently increasing with that recurrence interval. And then the third key bullet on here, the basis for estimating the damages, making sure that's as clear as possible. Again, if you're estimating damages outside of the model damages in the software, how did you come up with those estimated damages? Maybe you're applying a depth damage function, or a wind damage function, or a seismic fragility curve outside of the software. Make sure you explain how those estimated damages were reached, per the previous slide, if you're using the model damages, making sure those building characteristics are consistent with the assumptions being made in your analysis. Next slide. Finally, a couple of items related to general application best practices across the board. So now this isn't no longer about BCA but just overall, making sure you're referencing the minimum design criteria in your scope of work. And again, these need to be consistent with the programmatic requirements. So if you're proposing something like a safe room, that you're meeting 361, FEMA 361. If you're doing something like an elevation project, making sure you're meeting the Federal Flood Risk Management Standard, or FFRMS requirements, as well as ISE 24, which is a requirement for an elevation project type. You want to make sure you've provided any type of engineering and supporting documentation, especially if you're referencing it in your sub application. If any preliminary engineering was done, making sure you're providing that as well. If no preliminary engineering design has been started, oftentimes we see these projects as phased. Make sure you've identified that you intend to phase the project, and in phase one that you intend to meet XYZ design requirements. Again, pretty common example of that is something like a safe room project where no design has been done yet. You have a general idea of what size facility you want to build, and your intent is to make sure that the design meets FEMA 361 and ICC 500. So make sure you outline that in your sub application. And then finally, last bullet here, make sure you're considering program priorities in the notice of funding opportunity. This is especially important. We want to make sure that if you're getting points for meeting some of the qualitative and technical criteria, that your scope of work is also consistent with that. So in a moment here, it'll be point of emphasis. If you have something like a nature-based solution in your narrative, and you're seeking to receive points for that nature-based solution, make sure your scope of work and your preliminary design is consistent with that as well. Next slide. Last couple slides here for best practices. You want to make sure you're considering multiple hazards. Again, that may help you with providing the greatest amount of benefits. Sometimes we do see multi-hazard projects, and the benefit cost analysis, for example, is just looked at in one of those hazards, and benefits were left on the table. So make sure you're considering that especially from a benefit cost analysis standpoint. And then, as I mentioned on the previous side, make sure that if you're incorporating things like nature-based solutions or green infrastructure, sure that you've outlined that and throughout your sub application, so you're you're receiving points, and your sub application will be a little bit more competitive per the notice of funding opportunity. And next slide, please. And this is my final slide here, or final couple of slides here on phase projects. Making sure that if you are doing a phase project, that you've identified that approach throughout your sub application, and you've also checked that in FEMA Go. If you have any preliminary design data, you can submit that. If you do have some preliminary design data and still have reasoning for wanting to phase a project, that's you're allowed to do that as well. But again, we can't emphasize enough that if your intent is to phase a project, that you indicate your intent is to do that and outline what you plan on doing during phase 1 versus phase 2. Note that phase projects differ from scoping project activities. For a phase project to be successful, you should have a general concept for the project that should already be known. If you need help developing a concept or how to mitigate a hazard, then that's really intended to be more of a scoping, scoping project. Excuse me. Next and last slide, please. A couple other best practices to consider is to provide a detailed benefit cost analysis narrative. This should help the reviewer, see the assumptions that went into the benefit cost analysis. Make sure you've provided information for each of your inputs into the BCA software. One thing that sometimes gets overlooked is making sure you attach that benefit cost analysis exported from the BCA toolkit. And we encourage folks to attach it both as an Excel file as well as a PDF report. And if as much as possible, make sure it's clear and consistent where the attachments were for the inputs that were made into the analysis that go along with that narrative. The clearer and more organized it is, the easier it is for that reviewer to review that benefit cost analysis, and basically review it and reanalyze it, make these exact same inputs the sub applicant made, and allow them to recommend it for further consideration. That covers the points that I had. I'm now going to turn it over to my colleague, James Hines, who's going to get into specific project type pitfalls and best practices. James?
Yeah, thanks, Manny. Hi, everyone. Yeah, I'm going to go over the for some specific project types that we typically see submitted under BRIC and FMA. We couldn't cover all of the project types due to time constraints. So if you don't see your project type on here, go check out the HMA program and policy guide, which was released within the last year. It has really good information on all project types and what is required for when you're submitting for these grants. All right, we're gonna, next slide, please. We're gonna start off with common pitfalls and best practices for acquisition, elevation, and mitigation reconstruction projects. Next slide. So one of the best practices for these types of projects is to clearly identify the flood risk. When you're filling out your BCA, make sure you're using information from the flood insurance study, the FIS, and attach all of the documentation you used to that you picked out of the FIS along with your sub application, and clearly marking in the flood profiles where your structure is located. This will help us or help ensure that you've identified the correct flood elevations, and then that'll minimize your chances of finding out after submission that the project is not cost effective. If there's better information available, use the best available information. So that could be usually the effective flood insurance study, or maybe there might be advisory flood hazard information available. Sometimes also we'll see if there's a recently completed H&H, that would be considered the best available data. It's important to note that flood hazard data should only come from one source for a structure. So, discharges can't come from the FIS while water surface elevations come from an H&H study. You have to be consistent in the documentation that you're using to pull that flood data. When you're using the historical damages module, make sure to provide claims data if that's available for historic damages for each structure listed in the project. And then you want to make sure make sure that that you're verifying the lowest floor elevation and the number of feet that the lowest floor elevation or LFE will be raised, and then that's correct and consistent in your sub-application. Be sure to use the correct building diagram type from the elevation certificate if that's available to determine the LFE. Alternatively, you could use photos that clearly document the foundation height using a ruler or a measuring tape. These photos need to be accompanied by a topographic map that clearly shows where the ground surface elevation is and the maximum contour interval with a maximum contour interval of 2 feet. Next slide, please. For acquisition projects, a common mistake is the lack of documentation for the fair market value, or FMV, of the building. The best form of supporting documentation for that is a recent appraisal. If a recent appraisal is not available, other sources of estimating the purchase price are acceptable and should be used with and should be supported with documentation. The building replacement value, the BRV, is the cost to build a new structure of the same quality, but is not representative of the fair market value, which is the cost to purchase the property. If an estimate other than the best data quality option was used, make sure you include a line item in the cost estimate for an appraisal to be conducted once the project is awarded. For elevation projects, one of the pitfalls we see is lack of demonstrating the feasibility of that elevation. This especially applies to buildings of older construction, over 50 years old. This can be documented in the form of a narrative or cost estimate that shows that an engineer or qualified professional has assessed the feasibility of elevating the structure. In addition, the application should verify the final elevation certificate will be provided with the scope of work, the schedule, and budget. For mitigation reconstruction projects, the eligible costs for residential and non-residential structures are limited to $220,000 for a federal share. Some eligible activities, for example, administrative allowances and permitting fees, do not count toward that maximum federal share. The HMA program and policy guide has more details about this requirement. Another pitfall for mitigation reconstruction projects is having a structure size that is greater than 10% of the original structure size. The application should include verification that the final square footage is within 10% of the original square footage. The original square footage must be documented in the sub-application with copies of tax records or other verifiable means. And then finally, a mitigation reconstruction is not allowed in the V zone or the floodway. Next slide, please. Okay, so best practices for these projects. The best way to demonstrate cost effectiveness for these types of projects is using the pre-calculated benefits and the substantial damage waiver approach. You should ensure that all requirements to use these efficiencies are met. The application should clearly identify the project location, confirming the building footprint is in the special flood hazard area if pre-calculated benefits are used. When both pre-calculated benefits and traditional BCAs are used, be careful not to aggregate benefits. And this means you cannot combine pre-calculated benefits with benefits from the BCA toolkit to arrive at the project BCR. If your project includes both acquiring and elevating properties, then the pre-calculated benefits can be aggregated. In addition, if location factors are used to justify a higher threshold for pre-calculated benefits, appropriate documentation from standard cost estimating guide should be provided to support the use of this factor. When using the substantial damage waiver approach, proof of the structures being substantially damaged should be provided. This is often in the form of a letter from the floodplain administrator or other local floodplain official confirming the structure is substantially damaged. And finally, ensure that structures will be elevated or constructed in accordance with the Federal Flood Risk Management Standard, or FFRMS. Next slide, please. Next, we're going to talk about flood risk reduction projects. Next slide. There are several best practices to follow when you're putting together an application for flood risk projects. Remember to include pre and post H&H hydrologic and hydraulic data with water surface elevations for multiple recurrence intervals, and documented lowest floor elevations for all structures, or elevation of vulnerable infrastructures such as roads. We want to be able to compare the H&H data to those elevations in the BCA. And when you're calculating recurrence intervals, make sure you're using reputable sources such as an FIS report from models that support that FIS report, H&H models, stream gauge data from the USGS, and the National Oceanic and Atmospheric Administration NOAA Atlas for rainfall. For coastal projects, clearly identify the nearest coastal transect to the project site. As noted in our previous slides, make sure you're using the best available data for your project. Usually for flood risk, that means an H&H report if it's available, or using any preliminary flood hazard or the effective FIS. Clearly, make sure you're clearly defining the level of protection of the project. We need to know what size event, which size flood, which size storm the project will be protecting against. For instance, if you're upsizing a culvert, you'll want to say that what the existing capacity is, say it's a 10-year, and then that the proposed project would upsize the culvert to a 50-year capacity. That'll help define the level of protection and define what residual risks may exist. Finally, if your project is taking place within the SFHA, Special Flood Hazard Area, make sure that you're indicating whether a conditional letter of map revision and letter of map revision are necessary. Projects within the SFHA that alter the characteristics of the H&H are required to go through that process. And that's one thing that we look for in all flood risk reduction projects. Next slide. So there are several pitfalls we see typically with flood risk reduction project. As Manny mentioned, making sure that the scope of work is clear, and also that the project is a standalone solution. So we want to make sure that the project is addressing the problem independently, and it's not dependent on another project or another action to accomplish that goal. Secondly, we need to understand whether the project will affect upstream or downstream. So we want to ensure that there's no upstream or downstream impacts. A flood risk reduction project should not result in adverse impacts upstream and downstream of the project area. For example, a project that reduces flood for community should not result in negative impacts to a community downstream. And acceptable documentation for this would include a letter from an engineer or a no-rise analysis that shows that there won't be any negative impacts. Third, the H&H results may be based on a study that includes improvements other than the proposed project. Again, this is about keeping your scope of work clear, and so we can understand what the project is exactly doing. For instance, in this case, the project benefits may be skewed because the model results are based on additional improvements beyond those implemented by the current project. This may also suggest that the current project is related or dependent on other improvements to achieve the desired outcome. Next, regional estimates are sometimes used rather than best available site-specific data. It's important that the H&H study reflects information for the specific project site and demonstrates before and after impacts to that particular project, rather than a regional estimate. Another pitfall is the lack of supporting documentation for historic damages, downtimes, or recurrence intervals. We often see mitigation damages not included in the BCA as well, or that are inconsistent with the level of protection in the scope of work. most projects, except for acquisition projects, should have after mitigation damages that reflect the residual risk. Next slide, please. Next is soil stabilization projects. Next slide. So there are several best practices for these types of projects. For structures that are an imminent risk to erosion, the best mitigation measure is to acquire that structure and rebuild elsewhere. It will be difficult to demonstrate cost effectiveness for mitigation projects that propose measures in which an at-risk structure remains. The landslide acquisition BCA module can be used for acquisition of structures at risk of imminent failure. If this module, if you're using this module, the building replacement value should be supported by appropriate documentation, or you can use the $100 per square foot standard value. For slope stabilization measures that are intended to stabilize a slope so that structures and infrastructure are no longer at risk of failure, consider using the imminent failure methodology in your BCA. What this means is for both the project useful life and the recurrence interval used in the BCA, those will be the same value. So if the slope is at risk of failing within the next 5 years, you would use 5 years for the project useful life and 5 years for the recurrence interval. Damages associated with this recurrence interval should reflect damages that would occur if the slope were to fail and the structures and or infrastructure would need to be repaired and replaced. Typically, you'll also need to implement some sort of mitigation measure when the slope fails, which might look exactly like the project that you're proposing. So you could potentially include those as damages as well. For the cost effectiveness, be sure to provide the documentation to support any estimated impact days with loss of function. For example, if a landslide will result in a road closure, provide documentation that supports the estimated time that it will take for cleaning and repairing the roadway. And then again, like flood mitigation, and I think we repeat it in most of these, for most project types, make sure that residual risk is captured in your BCA. And for slope stabilization projects, that should reflect the probability of a future slope failure. Next slide, please. So common mistakes we see for slope stabilization projects is that we don't get a good description of what is intended to be protected. To be able to be eligible for funding, the project must propose to protect or reduce risk to lives and or property. For example, a roadway or utility line or structure. If the proposed project to mitigate the risk to a structure does not propose to acquire the vulnerable structure, the scope of work must describe how the project will mitigate future similar damage to the structure and the proposed level of protection. For cost effectiveness for these projects, we often see an incorrect application of the imminent failure methodology. Again, we really want to see that the recurrence interval or that time to failure is supported by documentation, and the best source of documentation for that imminent failure, that time to imminent failure, is from a statement from an engineer or a soils report that validates that time to failure. Incorrect. What we also see is that recurrence intervals based on historic damages must be careful to use the correct analysis duration and to provide supporting documentation for why the analysis duration was chosen. So if this is, if you're looking at historic damages and using 3 past events, this is when this applies. We want to make sure that you're using the correct analysis duration, or what you enter in for the time or the year that that infrastructure was built. After mitigation damages are representative of the residual risk and of the mitigation strategy, and should be supported by documentation. For non-imminent failure, if the recurrence interval is shorter than the project useful life, This will make it seem like the slope will fail multiple times instead of from one catastrophic failure. Next slide, please. Now we're going to discuss energy resilience and generator projects. Next slide, please. Best practices for generator and secondary power projects include ensuring that the emergency power needs are for critical functions. Eligible projects must protect critical facilities. Another best practice is making sure that the solution is complete by accounting for all required equipment and components of the project, such as having a transfer switch, fuel tanks, and supporting infrastructure, such as a concrete pad. In addition, ensure that equipment will be protected under multi-hazards, such as flood and wind. FEMA P1019 has additional information on best practices for emergency power systems for critical facilities. Next, be sure to describe the existing electrical infrastructure and how the proposed equipment will connect to it. This is important to understand how the proposed solution will fit with the existing infrastructure. For example, what improvements and what will be the improvements and what will be kept from the existing infrastructure. A clear basis of risk for the risk should be established based on the probability of the recurrence interval of that event and the exposure, what is the loss of function and the impacts associated with that event. And finally, be sure occurrences of loss of function are clearly documented. Examples of documentation include a letter from the utility detailing power outages, a narrative indicating historic power losses, and historical documentation of damage events, such as news articles. Next slide, please. Common pitfalls we see with energy resilience projects and generator projects is the lack of documentation, explanation to support the recurrence intervals and loss of function impacts, justification for various events that cause loss of power, as well as the impacts such as length of time of outage and population served should be provided. It's important to recognize that there is always residual risk for these projects. Common error is not including that residual risk in the after mitigation measures. For example, residual risk may be due to possible generator malfunction during a storm or natural hazard. Another pitfall we see is a lack of explanation regarding the basis for the required emergency power generation capacity. Documentation should be provided to justify the required capacity for that project. For example, when critical functions will need emergency power in the event of a disaster, and how that how does the proposed capacity of the project account for this, the need for that critical function. And then finally, a common mistake we see is selecting the incorrect service for the loss of function. For example, electrical services selected when the facility is a wastewater station that provides wastewater services. So in that case, we'd want to use loss of wastewater in the BCA. Next slide, please. Next, we'll discuss safe rooms. Next slide, please. So there are quite a few best practices for safe rooms. One of the best practices is providing a statement that the safe room will be designed and constructed in accordance with the most current editions of FEMA P361 or FEMA P320 and ICC 500. HMA eligible safe rooms must meet these standards. A statement should be provided that the safe room will comply with local building codes such as the IBC and ADA accessibility codes as applicable. Make sure that you include a conceptual floor plan that identifies the usable and unusable areas, restrooms with fixtures, mechanical, electrical, plumbing rooms, and emergency power systems. This will allow for when we review these projects to verify that the safe room includes ample usable area for the safe room occupancies specified, as well as the necessary safe room features as required by FEMA P361. Documentation should be provided to support the safe room type, safe room location, the total gross area, total usable area, period of occupancy, design wind, speed, protected population, and where this population is coming from. The usable area should accommodate the appropriate number of standing, seated, and wheelchair spaces. The design wind speed should be appropriate for the project location based on the wind speed maps from P361, and the protected population and where people are coming from will be important to understand both from a planning perspective and for the BCA. And then make sure when you're designing the safe room, making sure the internal pressure coefficient of plus or minus 0.55 as it is, making sure that is a part of your design considerations as outlined in FEMA P361. For the safe room rebate programs, the applicant should clearly define the criteria for the rebate and the expected number of participants. For example, what type of safe rooms are being funded, where is the rebate amount, and how many people are expected to participate, and what are the typical costs for a representative safe room, and how many people will use that safe room. Finally, the application should include a draft operation and maintenance plan, or at least a statement indicating that a final operation and maintenance plan will be provided at closeout. Chapter A4 of FEMA P361 has additional information of what should be included in that O&M plan. Next slide, please. There are several pitfalls with safe rooms. One mistake is to overestimate the safe room occupants. The occupancy and the benefits from that safe room will be determined by the number of people that can reach the safe room in time. A common mistake is to overestimate the number of people in the area when inputting the maximum occupancy in the safe room BCA. Documentation should be provided that clearly indicates the number of occupants and location where the safe room occupants originate from. This includes a breakdown of safe room occupancy for the 3 times of day listed in the BCA software, a day, evening, and night. Overestimating the protected population can also occur by use of a 0.5 mile radius for identifying the potential protected occupants within that radius. That's the safe travel distance for tornado safe rooms. According to FEMA P361, the maximum travel distance to the proposed safe room is 0.5 miles. Residences and businesses may be located within that 0.5 mile radius, but due to road access limitations, may be more than 0.5 mile travel distance from that safe room. The population should be this population should be excluded from the maximum occupancy, as they may not be able to reach that safe room within the warning time. For schools, future enrollment should not be used unless proper supporting documentation of this future enrollment is provided. Guidance for safe room sizing and usable area determination can be found in FEMA P361. Another pitfall is using historical damages in the BCA. Damages for safe rooms are based on the probability of the event taking place at the specific location. To use historical damages, it would need to be damages at the same exact spot, not for damages that occurred throughout the county or the state. Therefore, it is most appropriate to use the tornado safe room or hurricane safe room modules, depending on the hazard being addressed. Another pitfall is proposing to retrofit an existing structure to be a safe room without documenting the feasibility. The FEMA P361 has stringent design standards for safe rooms that are much higher than typical building code requirements. Therefore, extensive retrofits of existing structures are likely needed to convert that building into a safe room. The application should include sufficient documentation of these retrofits and their feasibility, preferably with input from an engineer. And finally, the project may have insufficient planning factors or logistic for large occupancy safe rooms. For example, the safe room must have ample parking spaces and usable area to accommodate a safe room design for a large occupancy. There may be a sudden influx of traffic that should be considered when planning for the safe room, and the application should document notes that these factors were considered to ensure that the safe room can provide protection for the expected population. All right, next slide. Next is wind retrofit projects. Next slide, please. There are several best practices for wind retrofit projects. These applications should include confirmation from an engineer that the roof, building envelopes, and structural systems will not be retrofit as part of the project, can resist current code level wind speeds. Current code level wind speeds can be referenced in ASCE 7 and by the ATC by hazards by location or ASCE 7 hazards tool website. A wind vulnerability assessment should be provided in the application, including the components that need a wind retrofit. The process for conducting a vulnerability assessment or VA is spelled out in FEMA P2062 with wind vulnerability of critical facilities. The purpose of the VA is to identify the vulnerabilities of the existing building so that the appropriate design code can proceed. To understand a building's wind resistance, the VA study identifies all significant wind and wind-driven rain vulnerabilities that could affect building operations. Next, verify that the impact protective systems are rated to the appropriate wind speed and missile impacts for that building location. And the process of inspecting and certifying the retrofit should be clearly spelled out to provide assurances that the components will be installed correctly and provide appropriate level wind protection. And documentation for the building properties before and after mitigation provided in the application should be provided in the application. This could include photos of the existing building, existing plans, and design plans and studies for the proposed mitigation. Finally, one may be able to benefit from opportunities to use pre-calculated benefits. FEMA has pre-calculated benefits for both residential and non-residential building wind retrofits, and these may be used under certain conditions. In addition, efficiencies may be available based on HMGP disaster. For example, Puerto Rico and the US Virgin Islands currently have a wind retrofit memo explaining cost effectiveness efficiencies for certain wind retrofit projects that address opening protection, roof retrofit, and load path. Next slide, please. There are several common pitfalls for wind retrofit projects. First, using impact protective systems with known vulnerabilities such as hurricane screens and films is a common issue identified for technical feasibility. While window film will prevent glass from shattering, if it's impacted by windborne debris, it does not provide strength to the overall frame or frame of the window. The glass can still fracture and dislodge. In addition, hurricane screens can protect against windborne debris. A section, as indicated before, another pitfall is making sure that it's not addressing all the wind vulnerabilities. Those are identified in the vulnerability assessment. So making sure that those are all addressed in the project. And then for non-residential structures, a common pitfall is using the pre-calculated benefits when the project scope of work does not include all the required items in that pre-calculated benefit memorandum. Next slide, please. I'm going to run through the next few relatively quickly because I know we're running out of time. Like I said at the beginning, some of these projects are covered in the program and policy guide. So for seismic retrofit projects, some of the best practices is to include a seismic evaluation report performed in accordance with ASCE 41. For retrofitting buildings, this report should note the procedures used to evaluate the building and identify areas of deficiency. These are typically complex projects that require a development of the technical approach. So we would like to see sketches of the proposed retrofit and analysis performed by a registered engineer that indicates the deficiencies that need to be addressed. If the seismic retrofit is for utilities, make sure that the supporting documentation is included for the duration of loss of service and the number of customers served by that utility. Like all things in the BCA, we really want to make sure everything is documented. Next slide, please. A couple of pitfalls for seismic retrofit projects. So when filling out the BCA and you're using historical damages, a city that experiences a magnitude 5.0 earthquake in 2010 and another one in 2012 does not mean that the recurrence interval for that event is 2 years. The recurrence interval for a seismic event should be based on the average time span between earthquake occurrences of a similar magnitude on a fault. Let's see. Another pitfall we see typically, or a lot of the time with seismic projects, is the dual probability of an event occurring. For example, an uncontrolled fire and loss of potable water during an earthquake. It should be noted that fires and utility losses don't always happen 100% of the time because of an earthquake. And if those damages are associated with these events are included, documentation should be provided to demonstrate the probability of these events occurring when an earthquake happens. All right, next slide, please. Okay, next we'll discuss wildfire mitigation projects. Next slide. So one of the best practices for wildfire projects is if you're not using the default burn recurrence intervals within the BCA software, providing that supporting documentation to justify those non-default recurrence intervals needs to be provided. And you can usually get those from the local fire management authority or Forest Service, or an individual or professional with wildfire expertise. So another best practice is making sure that the project meets FEMA eligibility requirements and recommended best practices. When developing the scope of work, you want to make sure that all the activities are eligible ones. For example, projects that are for the purchase of fire-related equipment, such as trucks and or vehicles, or projects that are for irrigation of vegetation to avoid disease or drought-related infestation, are ineligible activities per the guidance. And then for defensible space projects, we want to make sure that there is a clear description of the proposed defensible space activities for the project. All right, next slide. So a common pitfall, with I think probably the most common thing we see with wildfire mitigation projects is implementing ignition resistant construction without defensible space measures. According to the HMA program and policy guide, ignition resistant construction is not an eligible activity on its own and must be combined with defensible space measures. And there's more information in the HMA program and policy guide about that. All right, next slide. Next is drought projects. We'll discuss drought projects. Next slide, please. Probably one of the hardest parts of a drought project is defining recurrence intervals. Since these are location specific, they should be based on supply monitoring data, and that data might only be a few decades old and it might be insufficient to develop recurrence intervals. A relatively easy method for determining recurrence intervals is to use the standard precipitation index, or SPI, as a z-score. SPI is calculated using the same formula as a z-score. Therefore, a z-score table can inform the probability of a specific SPI value, which can then be used to calculate the recurrence interval. So for technical feasibility, probably the most important best practice is to provide clear and comprehensive documentation of the sub-applicant's rights to withdraw water from an existing resource or withdraw from a new resource as a result of the project. This documentation will be locally and regionally specific and can take the form of a memo of understanding with a agency that is responsible for the water rights in that region. Next slide, please. A significant pitfall, so one of the main ones we see is that that the documentation is or not documenting the deficit between supply and demand due to increased demand rather than increased supply. In other words, the supply remains the same during drought events, but the demand increases. Drought projects must document an impact to water supply during drought events in order to be cost effective. Another pitfall is over-reliance on population growth and projected demand. Since droughts are typically larger infrastructure projects, they can take multiple years to construct and implement. Use of projected population demand is allowable within reason. For example, a 5-year planning target, but some projected values may be too far in the future and rely on too many assumptions to support cost effectiveness. And then we recommend testing the BCA sensitivity to confirm that the project does not rely on projected population. All right, I'm going to skip the next 2 slides and hand it back to Melanie to discuss EHP.
Hi, thank you, James. When FEMA is considering funding for a grant, it becomes a federal action and is subject to the compliance with a variety of laws and executive orders. Sometimes FEMA will be required to consult with other agencies and tribes. The EHP review is the process of complying with those federal laws, regulations, and executive orders, along with documenting the consultation process. In the next few slides, we'll touch on a few of those items that EHP will require to streamline the review of your grant. Next slide, please. To complete the EHP review, there is information about the proposed project that is needed. This information includes a detailed description of the scope of work, a project area and structure information, details on existing conditions of the project area, and potential impacts on people, environment, and cultural resources. Providing this information will help to streamline the EHP review. The scope of work should include what you are proposing to do, how you're proposing to do it. Documents that assist in understanding the scope of work include engineering documents and conceptual design plans, maps of the project area and features, access information and staging locations, alternatives to a project that were considered, and the project schedule, including time of day and time of year restrictions on work. Providing GIS shapefiles or KMZ files of the project area and staging locations help EHP reviewers and can streamline the review of your project. For a project area and structure information, EHP reviewers will need to know where the proposed project would be constructed, as well as structures and infrastructure that could be affected by the project. This is most easily shared using GPS coordinates or detailed maps and GIS files. For structures in the project area, it is helpful to know the year the structures were constructed, any previous modifications that have occurred to those structures, and have photos of all sides of any structures that may be more than 45 years old. Information on existing conditions is used to explain the project area to the EHP reviewer who may not have the opportunity to visit your project area. Important information includes existing structures, ground cover, vegetation, and land uses. It is important to know if the ground has been previously disturbed, for what reason was it disturbed, and to what depth it was disturbed. Often photos of the site can help the assessment of previously disturbed soils. Next slide, please. If there have been any previous studies in the project area, even if it was for a different project, these could also prove to be helpful for your application. This information may include previous public notifications or outreach documents, summary of any input from public, previous consultation documents, permits, previous studies such as cultural or biological studies. If work were to occur in a floodplain, it is helpful to describe any changes that would occur to the capacity of the floodplain. That is, would the project put any fill in the floodplain? If so, you may need to provide a hydraulic and hydrology study. In addition, if your project is in or near surface waters or wetlands, please describe any measures that would be taken to avoid work in water and or wetlands, along with mitigation of any impacts. Next slide, please. Now, due to the sake of time, we don't have time to go through each one of these boxes, but I will summarize it a little bit. These boxes just organize information that we need by the resource type. The more of this kind of information you can include in your application, the more smoothly your EHP review is likely to go. Next slide, please. Job aids are documents that are specific to a project type, such as soil stabilization or risk reduction. The job aids provide the specific instructions to develop a project application based on the project type. The information that should be included in the application is described through a series of questions and examples in each of our job aids. In addition to the job aids, there are a list of documents developed by FEMA that provide guidance on the HMA process and EHP reviews. They further describe the EHP review process and identify regulations and directives applicable to EHP reviews. These additional resources will be available for download on the webinar website along with today's slides. Later in the presentation, there's a resource slide. There you will also find helplines you can email or call with specific questions that you may have. Thank you for your time, and I'll now hand it back over to Eric for additional considerations and to wrap us up.
Thanks, Melanie. So we had a couple of some additional consideration slides, but we also have a decent number of questions. So I think it probably makes sense to move to the resources slide because we've all referred to resources throughout this presentation and don't want to leave folks hanging with not providing those. So if we could move forward, I believe it's going to be 3 or 4 slides. Perfect. So we all mentioned the HMA program and policy guide, the program support materials. Melanie mentioned the EHP job aids, and there were job aids for on the technical side as well. And then there have been a number of questions around, where you can find specific resources around the BCA. So that little cursor was circling there right around the main landing page for the BCA website. And then within there are some subsections that we'll kind of discuss a little more in the Q&A. And then finally, if we can't get to your question today and it relates to cost effectiveness, FEMA's BCA helpline is a great resource, and there's an email and a phone number that you can reach out to there. So with that, I will turn it over to Rafa, who's going to help moderate the Q&A and leave you with a handful of more resources that will help you, again, with more program requirements, resources in terms of state hazard mitigation officers, and a number of resources around the EHP requirements that Melanie touched on.
Thank you, Eric, and thank you, team, for a great presentation. So our team has been working in the background, preparing answers for all the questions that you have been posting in the Q&A chat. And we are going to start actually back to Eric, who is going to help us with some questions that you posed regarding the streamlined BCA and related to that. So Eric, please, can you take some of those questions?
Happy to. I'm going to leave my camera off because I'm looking at the answers that we wrote over on the screen. And as Ralph mentioned, there's a number of questions that touch on the streamlined determination, that $1 million threshold of the question. And then we have is, I saw this new streamlined determination method states that projects must have a total cost of less than $1 million. Is that per property, or would it include all properties on the flood buyout application for a particular sub-applicant? This is applying for a demolition project of multiple single-family homes. So $1 million threshold applies to the total project cost. So for your example, pre-calculated benefits for acquisition projects, which are currently $323,000 per structure, if I'm getting that right. As long as they're in the special flood hazard area or are repetitive loss or severe repetitive loss structures, that could apply. And, you know, of course, if neither of these two streamlining methodologies apply, then you could use the toolkit to demonstrate the cost effectiveness of your project. And I see a message that I'm cutting out. Is this any better, or does somebody want to take over for my answers?
Just a moment, Eric. Now you sound well.
Okay. I bet I know what happened there. Okay, I was looking at the other screen and I think my head was turning. So the $1 million threshold applies to the total project cost. But if that doesn't apply, you can, of course, use any of the other BC efficiencies, including pre-calculated benefits, or use the toolkit to demonstrate the cost effectiveness of the project. The other questions that I was asked to cover for the streamlined BCA, where can we find a complete or more substantial list of project types with pre-calculated benefits? And there was a very similar question of, I just see a couple there. Where are they? So on FEMA's BCA website, there is a header or a subheader that says streamlined BCA, or how to complete a streamlined BCA. In this location, you'll have the full list of the project types where pre-calculated benefit applies. When you scroll down, you'll first see links to 3 memos that document the pre-calculated benefits for a couple activities. But if you go past that a little bit, there is a table that has kind of the full list of pre-calculated benefits, including acquisition, elevation, wind retrofit, wildfire mitigation projects. So that was 2. And then the final question, I believe, that I was asked to handle for projects under $1 million where pre-calculated benefits or professional expected damages, professional expected defaults are available, can the BCA narrative methodology still be used? So short answer, yes, as long as the project is under $1 million total project cost, so this is federal and non-federal share, the BCA narrative can be used. That said, I would recommend considering which approach is the most straightforward for your project. For instance, if it's, demonstrating conformance with the pre-calculated benefits may or perhaps may not be easier. So you can certainly use the $1 million threshold if your project is under that threshold. But again, some of the other BCA efficiencies that are out there may actually make it easier for your project to be considered cost effective. And then finally, the last one I have, this relates more to the pre-calculated benefits. If there are 20 properties to be acquired and 15 meet the pre-calculated benefits limit and 5 have a full BCA, so this is in the BCA toolkit, but you don't combine all 20 projects to get the overall project BCA. So that's kind of the question is you cannot combine them, correct? So the 15 structures that meet the pre-calculated benefit requirement need to be evaluated separately from the 5 that require a full BCA. This doesn't mean they have to be part of a separate application, but both kind of subsets of properties would need to be shown to be cost effective. And Rafa, I believe that covers those that I was asked to cover first. So back to you.
Thank you so much, Eric. The next topic, there were a couple of questions regarding the community disaster resilience zones. So the first questions, we're going to get Woody Jones to help us answer those, please.
Hey, Rafa. So we got a question in the chat that was asking, what if CDRZs don't apply? Many states can't just solicit CDRZs to apply due to procurement law. And so we do have a process for that. And we at headquarters have shared this with the FEMA regional offices, so they have information on this as well. But the FEMA regional office may entertain a waiver from applicants in limited cases, such as, but not limited to, a lack of interest in BRIC support, technical assistance, and or funding from CDRZ communities within its jurisdiction, a lack of cost share for activities to benefit CDRZ communities in its jurisdiction, or a lack of time between the CDRZ designations for territories and tribes by the application deadline. So if one of those 3 things apply to you, you can request a waiver. The applicant must provide information in writing to the FEMA regional office describing the conditions for which a waiver is being requested prior to the application deadline of February 29th, 2024. If that information is not received, FEMA will contact the applicant during the eligibility and completeness review phase, which will happen in March 2024, to obtain the needed documentation. And an email from the applicant to the regional office is adequate documentation. We had a follow-up question related to CDRZs that asked, if CDRZ apply for BRIC direct technical assistance instead of a project or plan sub-application, how will that be quantified towards the $400,000 requirement? BRIC direct technical assistance, or DTA, is non-financial direct technical assistance, so that would not count towards the $400,000 requirement for CDRs. And I think the two questions.
Thank you so much, Woody. That was really helpful. And we're going to follow up a little bit with CDRCs, and that was another follow-up questions about primary benefits. And Charlie Carson is going to help us with that one.
Yeah, thanks, Rafa. So we had a question on how is it determined whether a project primarily benefits a CDRZ? I did want to highlight, and I believe this has been dropped in the chat, but the RAPT, RAPT, Resilience Analysis and Planning Tool has released the Grant Equity Threshold tool, and it provides important information regarding community populations, including the Climate and Economic Justice Screening Tool, Disadvantaged Communities, FEMA's Community Disaster Resilience Zone, or CDRZs, as well as FEMA's Community Resilience Challenges Index, or CRCI. So this tool can help grant applicants demonstrate how their potential benefiting area supports the Justice 40 initiative by focusing on efforts on disadvantaged communities and tribal lands. The GETT also provides applicants with benefiting area shape files, which are submitted with their application. So there will be more information on that in the chat and a link to that as well. And I should note from the NOFO itself, it does say sub-applicants could use FEMA's data to submit a map and associated geospatial shape files. So that includes a shape file, KMZ or KML, geodatabase, or other GIS-enabled document, delineating the estimated benefiting area from a project. Community disaster resilience zones are defined at the level of the census tract, which is the smallest geographic unit for which reliable nationwide data exists to support risk ratings. And a proposed project may include a benefiting area covering portions of a census tract or tracts or multiple census tracts. The proportion of benefits going to the community disaster resilience zone tracts will be identified using a weighted population formula, and a project with at least 50% or more of the benefiting population in community disaster resilience zones is eligible for the increased cost share and prioritization points. And somewhat related, but slightly different, I think there was a question that was, yes, what is the definition of small and impoverished communities? The program term small and impoverished communities, or excuse me, economically disadvantaged rural communities is synonymous with small impoverished communities. And that is defined at 42 US Code section 5133A. And it means a community of 3,000 or fewer individuals identified by the applicant that is economically disadvantaged, with residents having an average per capita annual income not exceeding 80% of the national per capita income based on best available data. So Rafa, back to you, unless there's other follow-up questions on those two parts.
That's great. Thank you, Charlie. Before we get into some other questions, we still have a few more that we are going to answer. I want to remind you and let you know that you will now see a set of polls that is going to pop up on your screen. And if you could please provide us your feedback, we would greatly appreciate. And as that's going, we're going to continue answering some questions. So we're going to move into some additional questions on BCA, related to BCA, that we're going to get help from Manny Pertin to answer. Thank you, Manny.
Great. Thanks, Rafa. And I've got one, I think I've got two right now. It's 12 and 16 on our list. I'm looking at the Word doc. So similar to Eric, I won't turn my camera on, but please let me know if my sound gets bad. So the question was, is there a recording available of a webinar that walks you through how to use the BCA toolkit? I'm particularly interested in how to determine the recurrence interval. And off the top of my head, I'm not aware of a readily available FEMA webinar that walks you through how to use the BCA toolkit, but encourage you to start with going to the FEMA BCA website, the one that Eric pointed out earlier. On that website, there's a how to perform a full BCA, so how to perform a full benefit cost analysis, which walks you through how to use the toolkit online or via desktop software using Microsoft Excel. It has other instructions in there. I'd start there. After that, you can reach out to the benefit cost analysis helpline, the FEMA BCA helpline, which was in the resources screen, or it's actually on slide 59 if you still have that up or available to you. Again, if you need assistance with either the toolkit or the BCA, how to do a BCA, or maybe some help on how to determine the recurrence intervals, you can reach out to that resource. And then I do want to note that some states and territories may have webinars or other resources online to assist with completing a benefit cost analysis as well. So I'd check with your respective state or territory or hazard mitigation office to see if they have any assistance that they can provide, or webinars or tools and things of that nature as well. And I think the last one I have, or the other one I have, was one that came in here towards the end. Would a project fixing a levee count as a flood risk reduction project? I'd say possibly. I'd encourage you to see the HMA guide. Look at in that guide, if you read the guidance on non-localized flood risk reduction projects, there's a possibility it could fit in there. The question was with respect to fixing, so just keep that in mind. For something to be eligible, must include an increased level of protection, not just the repairs, and that goes across any project type, not just a flood risk reduction project. So hopefully that assists with those two questions. And Rafa, I'll turn it back over to you. Thanks.
Thanks, Manny, and thank you for taking the last one so quickly. Thank you. And we're going to finish with the last two questions that we had. One related to the BCA narratives and another about the building codes. And David Ratte is going to help us with these two.
Thanks, Raphael. Yes. So we received a handful of questions on the BCA narratives in terms of how to prepare them and how we might be reviewing them. Of course, for review, our approach will be fair and consistent, so that whether or not they're being reviewed at the headquarters level or at the regions, we're making sure everything is applied consistently. But in terms of preparing a BCA narrative, we'd like to refer you to a program support material titled Demonstrating Cost Effectiveness for Projects Less Than $1 million. This has some information that should be helpful in terms of key elements to include in your narrative, so that one could easily assess benefits and, of course, compare those to the the cost of the project. And so the link to that program support material will be dropped into the chat if it's not already. And then also a question on technical scoring for the Building Resilient Infrastructure and Communities program. So the question I will paraphrase as it applied to a specific geographic location, but this could apply to a number of states and territories and tribes. So there's an understanding that some states and territories have trouble scoring well on the BRIC national competition due to a lack of statewide building codes. So the question is about revising the FEMA technical criteria to help that situation and looking at local building codes. And so if you look at the FY23 BRIC NOFO, you'll see some changes and updates for the technical criteria, and one in particular for building codes adoption and enforcement. And it includes rewarding points for local adoption of building codes. So we invite you to refer to the published notice of funding opportunity and the program support material describing those changes. Also, there is a technical and qualitative criteria webinar that will be posted online with more information on those competition criteria. Of course, FEMA recognizes the importance of building codes and standards as part of our nation's climate resilience strategy, and it remains a priority for the BRIC program. So for this grant cycle with BRIC, there's also a set aside, I think this was mentioned at the beginning, of additional funding dedicated for building code activities. This is called the Building Code Plus Up. It includes $112 million across all the states and territories. And it allows each state and territory up to $2 million for building code activities. Rafa, I'll turn things back to you.
Thank you, David. We're going to close, so I would like to thank you all for your interest in FEMA HMA grant programs and for participating in this webinar. And as we previously mentioned, the webinar was recorded and it will be posted online. If you have any additional questions, please refer to the links that were provided in the webinar and the program support materials that you can find also in our website. So thank you all again and have a very good afternoon. Thank you.